Today's topic is multiple regression and analysis. So, in marketing research, this is unit 9, and in unit 8, we cover the simple correlation and simple regression. But in this unit, we will talk about multiple regression analysis. The contents are multiple regression analysis concept, then conceptual framework and computational aspect of multiple regression, using of SPSS to solve the multiple regression problem, then considerations for multiple regression analysis with a brief summary. After completion of this unit 9, we will be able to appreciate the application of multiple regression analysis in the context of marketing research, and we will be also able to how multiple regression analysis is computed, that we can explain, and to interpret the findings of multiple regression analysis, how it is different from simple linear regression analysis, and to access the considerations of multiple regression analysis in many different problems, and also apply the concept learned in real world and marketing decisions, how it is impacting and how the solutions is required for a investigator while conducting any kind of marketing research. As we know from the previous chapter, that regression, which is a tool of prediction. With the help of regression, we are predicting our future with another variable when one variable is given. So there are, in previous chapter we also found out, as it was a simple linear regression model, there are only two variables. One is dependent variable, another was independent variable. Dependent variable is what? Now that variable which depending on another variable changes. In one change in independent variable, that is impacting the dependent variable. So regression analysis aims to explain that variation among these two variables. But what I am saying repeatedly, there are two variables. These two variables are actually exist in linear regression analysis. But in multiple regression analysis, as I am saying, it is multiple, means more than two variables exists in this topic. So the variable was explained, the variable used to explain the variation are called independent variable, as we know, and the another variable which is only depending on that variable is known as the dependent variable. So this relations is explained in the regression analysis, and in this particular topic we will discuss, or you can say we will focus on multiple regression analysis and building the concept of simple linear regression analysis, which is actually related with each other. In general, multivariate technique of analysis means it is more than two variables. I am not saying it is one variable or more than one variable, as because when there is a question of correlation or question of regression, then we definitely go for two variables. Otherwise, we cannot calculate any kind of relation or association between themselves, and also we cannot one variable. Also, we cannot predict one variable when another variable value has given to us. So, when I am talking about multiple, then I am definitely start from two variables, not from one variables. So more variables are involved here, and also simultaneously affecting another variable in this context of multiple regression analysis. So if we see the regression analysis, it measures the relationship between dependent variable and a set of independent variable, but it does this by fitting the statistical equation which we have already discussed, that is y equal to a plus bx, where y was the dependent variable that is depending upon the x variable. The equation was like this: y is equal to a plus bx. So here the variable y is determined by the value of x. So it means here the x is a independent variable. So this independent variable is now impacting the dependent variable. What we have covered in our linear regression equation, and A is what? Now A is the constant and B was the slope of the equation. But what is happening here, as in the linear regression is explaining this kind of two variable, but in multiple regression analysis, y y will be a function of many variables. It may be x1, x2, x3 and so on. So these are the independent variable, or you can say set of independent variables are there, and that is a dependent variable. So this is also happening in industry, in human resource analysis and also in marketing research analysis. But particularly in marketing research analysis, there are n number of variables. They are known as independent variable and they are directly impacting the dependent variable, which is most important to learn and understand how they are impacting before launching of any product, before improving their promotional activity, or before giving any kind of facilities to that product. So it is used to study particularly the combined influence of several independent variables. As it is seen, there are n number of variables can exist in a market. So if there are n number of variables and they are impacting the variable y, which is a purely dependent variable, so it is called the combined impact which is affecting the variable y. The example I have cited here, the demand for a product can be influenced by multiple factors like price, consumer incomes, and tastes. So many things can be possible, but I have given only four factors, and these four things I said, that price, consumer income, and tastes. These are the independent variable, and they are affecting whom? Now, the demand. Demand is the dependent variable who is purely depending on these variables. So researchers use regressions to explain variation in a dependent variable and for prediction of the prediction, or you can say forecasting the same dependent variable. So it's a widely used technique in the marketing research. As we know, it is a tool of prediction, and also it helps us to find out the relationship between the variables. And the second thing is, it examines how a dependent variable is influenced by one or more independent variables. As we are seeing that demand was there, demand was impacted by whom? Now taste, then income, and the previous variable was income and price of the product, and price. So let us assume that it is x or x1. You can say it is x2. You can say, and it is x3. So these variables x1, x2, and x3 are impacting whom? Now the dependent variable demand. So if it is impacting, or you can say if these variable has a great impact on demand, then what is that impact? How it is affecting the demand, and what is the context, what is the depth of impact? This could be calculated by the formula, or we can say by the tool or statistical technique, that is multiple regression. So here we have n number of, or you can say set of independent variable with us in our research, and there is only one dependent variable. And here we are interested to compute or to calculate the multiple, or you can say the combined impact of this independent variable on the dependent variable d. In a simple linear regression model, like d is equal to a minus bb, shows the relation between one dependent variable d and one independent variable b. So, in the previous example, what I had cited previously, and it is also slightly mentioned over here, that D is equal to A minus BP. So here what I told, now D is the dependent variable, but the only independent variable was P. So price was only thing or only factor which was impacting demand that we previously know. But when in with the price there are any other variable is hampering or it is affecting to the demand, then it will be termed under multiple regression analysis. So a multiple linear regression model analyzes the combined effect of several independent variables. I'm repeatedly saying that there are more than one variables, independent variables exist in the multiple regression analysis, and we are here to examine their individual impact on the dependent variable. For example, the equation D is equal to A minus BP, which was I had written here, was for linear regression. But if I am adding that C plus Q, C plus Q, then what happened to that same equation? Now it represents a multiple linear regression. As because P was only independent variable previously, but now we have another independent variable, that is Q, that is industry product, let us take. So price now in the same equation now become linear multiple regression by adding another independent variable, that is Q. So it was all about the concept of multiple regression analysis, which can easily understand if one independent variable is there, then it is linear regression analysis. If more than one independent variables are there and one dependent variable only, and we are calculating the impact of set of, or we can say combined impact of these independent variable on dependent variable, then we will call as multiple regression analysis. Let us take a scenario that a marketing, one scenario in the marketing research, that a marketing manager wants to understand how different promotional activities influence monthly sales revenue of a product. As we know from a research problem, we can go for the research questions, or we can develop the objective, then we will develop an objective, then research hypothesis. All these things are possible. So here in particular situation, the scenario is a marketing manager wants to understand, the question is how different promotional activities. So this is a combined thing. Different promotional activities influence monthly sales revenue of a product. So we can see here the who are the independent variable over here, and what is the dependent variable. So dependent variable is clearly mentioned in the last, that is monthly income. Here, that is monthly income. Promotional activities are the set of independent variable, and monthly sales revenue is known as the dependent variable. So what should the possible research questions from the research problem? Now, how do advertising expenditures, sales promotion, discounts, and number of sales calls affect promptly in monthly sales revenue? So let us come now defining these variables. Let me underline this. This sales promotion discounts, number of sales calls, and advertising expenditure. So how many things are there? How many things I underline? That one is expenditure, advertisement expenditure. Second is sales promotion, sales promotion discounts, and third one is number of sales calls. So what are they? My question was how the different promotional activities. It is here This monthly sales revenue was what? Monthly sales revenue, it was the dependent variable. I am writing DV for the dependent variable, but what are the independent variable as per the questions? The question says there are three things. Independent variable, these are in the question it is mentioned different promotional activities. But in research question we defined all the variables independently. The first number one was advertisement, advertising expenditure. Second was sales promotions. And the third was number of sales calls. Let me give the variable name as x1, one independent variable, x2, another independent variable, and x3 is another independent variable. So how many independent variable now I have? That is equal to 3. So three different independent variable is impacting the dependent variable called monthly sales revenue. So it means it is a case of multiple regression analysis, or it is not a case of linear regression analysis. If there is only one variable that sales revenue dependent variable, and suppose say advertisement expenditure was only one independent variable, then what will happen? Now if this is the case, then we can say that it is a case of linear, or you can say simple linear regression. But this is the case if this is the case, this is called multiple regression analysis. So let us talk how the research question will be, or how it will be looks like when it is a case of simple linear regression analysis. Now the research question will be something different, and similar the same way the scenario will be little different. That there should not be promotional activities, but we can say directly say that what is the impact of advertising expenditure or sales promotion or number of sales calls that influencing monthly sales revenue of a product. So it is the difference between the multiple and linear regression equation, and this is the way how we will find out, or how we will identify the list of independent variable in the problem or in the research questions, so that it will be easy for the researcher to collect the data in that direction. As because In this particular situation, I have three different variables. This is monthly, this is advertisement expenditure, sales promotion, and number of sales calls. So while I am conducting the data, collecting the data for this particular problem, then I will definitely give focus on the advertisement expenditure, then I will again go for the sales promotion data, then number of sales calls. So this is how a research scenario from a research question is derived from the research scenario, and this is how we will identify the research problem from the scenario, and that will be clearly mentioned in the research questions, and that way followed by the research hypothesis. Now coming to the objectives of the multiple regression analysis, the first objective is to study the general underlying pattern connecting the dependent variable and the independent variables by establishing a functional relationship between these two. In this equation, the degree of relationship is derived. Actually, in regression particularly, how it is different, the degree of relationship we are measuring in the regression analysis. So here also in multiple regression analysis also we should understand the pattern of connection between independent and dependent variable which is exist between them. So in the second application or objectivity is to use the well established regression equation for the problem solving, or you can say forecasting or predicting. Third is to study how much of the variation in the dependent variable is explained by the set of independent variables. By determinant of coefficient we have explained in the previous slides. This would enable us that to remove certain unwanted variable from the system which is actually not impacting but that exist in my study. So I must remove them from my study. So for example, one example I had cited here that if 95% of the variation is in demand in a study could be explained by price and consumer rating index, then the researcher may drop other factors like industrial production and the extent of imports, substitution effect, etc. So which may contribute to only 5% of variation in demand provided all causal variations are linearly independent. Now, before going to the model of the regression, or you can say the model of the multiple regression analysis, which is a little bit different from the linear regression model, we must assume the assumption that the relationship between x and y is very linear and y is random, but a random variable which follows a normal distribution from which sample values are drawn independently. Then third one is x1 is fixed and is non-stochastic, or you can say non-random. Non-random means the difference between random and non-random. If it is random, then it is purely with the help with the hand of nature, or we can say we cannot do anything, any changes in that variable. But when I am talking about non-stochastic or non-random, it means there is a question or there is some scope that a person can change the variable values, or we can say, give any kind of changes in that particular value which is not non-random. The means of all these normal distributions of y as conditioned above, and it is x1 lie in the straight line with slope beta 1 that was explained in the previous linear regression equation should present in the multiple regression analysis. And one more thing is there in the multiple regression analysis, that is epsilon, or which is denoted as error in the term, and the assumption that the mean is equal to 0 and the standard deviation is equal to sigma square, and independent of x1. X1 is the random variable which should not be present in the assumption of the multiple linear regression model. Coming to the model of the multiple regression analysis, we can see here how many coefficients are there. In the previous chapter, in the linear regression model, we have only beta 0 and beta 1. Only two coefficients were there. One was slope and another was the constant. But here, as it is a multiple regression analysis, there are multiple independent variable. So as for the previous model, there is a constant, that is beta 0, but we have another coefficients which is given for the number of, or you can say set of independent variable, that is beta 1 x1, beta 2 x2, so on up to beta k xk. Here x1 x2 x3 up to xk, these are the independent variable, but the beta 0 is known as the beta 0 is known as the constant of this model, and y is clearly notated as in the left hand side of the equation. It is known as the dependent variable. So this y is now depending upon this set of x1, x2 up to xk independent variable. So to understand the concept clearly, let us study a case of independent variables estimated regression line based on the sampling, which is I had written in the 9.2 equation, that is y equal to beta 0 plus beta 1 x1 and beta 2 x2 plus y u. So what is the value work of u? Now it is nothing but the constant term we have added here as per beta 0, and some error term must be there in the next model of the multiple regression model analysis. So in the 9.3 equation, if you will observe, there is something different equation I had written here, but it is why I wrote it. Now, these are the estimator of this model. So here these are not looking like the model, or you can say the equation of the multiple regression, but these equation 9.3, 9.4 and 9.5, they are the estimator of the model, as because with the help of these normal equations we will find out the different value of the variable which is used in the multiple regression. So you can see here there are three parameters, that beta 0, beta 1 and beta 2, that we have noted as b0, b1 and b2. They are to be estimated, because after solving these three equations we are going to find the value of b1, b2 and b0, and that are estimates of, as I said, these are the estimator. These three equations will give us some estimated value which will be help us to put in the multiple regression equation. So B0, B1 and B2 are the estimates of beta 0, beta 1 and beta 2 obtained through the method of least square. So these are the normal equations, and this will be solved by a method of least square by minimizing some errors that will definitely exist. Why this error term is coming? Now, as because the data is collected by human being, so there is always a assumption that some error will be there. After data mining and data cleaning also, there must be some error. So to eliminate that assumption, we definitely have to keep a error term in any statistical model. That is why we had mentioned always in every model to minimize the error, and that is why we are taking the help of method of least square to estimate these parameters. So let us see how it is derived. The summation y is equal to n beta 0 b0 cap, or it is otherwise noted as studied as b0 hat plus b1 summation x1 plus b2 hat summation x2. So it clearly shows that there are two independent variable x1 and x2, and this summation y is known as the dependent variable. Coming to the 9.4 equation, we can see I have taken here summation of x1 and y is equal to b0 hat into summation x1 plus b1 hat into summation x1 square plus b2 hat summation x1 into x2. That I will explain how this summation x1 and x2, how summation x1 and y will be calculated from the questions when we will do or solve one problem by multiple regression model. Then coming to the 9.5 equation, we can see here now in the first equation there was no x1, no independent variable. But in finds equation 9.4 we found one independent variable with a dependent variable, And in equation 9.5, we can see that with independent variable x2, we have the dependent variable. So what is the linear normal equation for the 9.5? That is b0 hat plus summation x2 plus b1 hat summation x1 into x2 plus b2 hat into summation x2 square. So by solving this three normal equation, we will be able to find out here the parameters b0, b1 and b2. After finding this, we can be able to go for the multiple linear regression model, which is our study today. So coming to the 9.6, b0 hat is equal to y bar minus b1 hat x1 bar minus b2 hat x2 bar. Then it was the all the normal equation we written. But the now problem is in the questions, whatever question till now we have solved, only two variables or three or four variables are given. So definitely they are in terms of x1, x2 and x3. And sometimes the one, suppose dependent variable one is given. So with the help of this variable, we can find out any solution in terms of x1, x2, x3 or y1, y2, whatever variables are given, we can find out. But now the question is, from this information, how we will find out this b1, b0, b0 and b2. Unless and until we have this value, we cannot address this kind of normal equation. And unless and until we have solved this kind of normal equation, we cannot move to the multiple regression model. So we need to understand definitely what are the formula for b1 and b2 or b0 in terms of x1, x2 and x3. No doubt there would be definitely problems, a solution for that or the formula for that, but that should be in terms of the information which is given to us. Otherwise, we cannot solve this kind of problem or this kind of formula in the multiple regression model. So let us see how B1 is defined in terms of the independent and dependent variable. Now, 9.7, we have defined the formula for B1 hat. It is summation x1 and y, which is multiplied with summation x square minus x square y, which is multiplied with summation x1 and x2, which contains in the numerator of the formula. Similarly, in the denominator, we have summation x square, which is multiplied with summation x2 square minus summation of x1, x2 values square. The same way we have defined the in the 9.8, the B2 hat formula. So here I have explained how we will get small x. As I said, the information which is given to us in terms of capital X1, X2, X3, or it may be up to xk. At the same way, for dependent variable, it is y1, y2 or whatever number, capital letters, symbols has given and the value has given. So now the question is, we understand how B1, B2, how B2, B0 will be find out in terms of x1, x2, but what we observed there, the x1 and x2 and y1 and y2, whatever terms I have used in the formula, that is in terms of small letter. That is B. This x1, I had written the small x1 for x2. In my formula, it is small x2, and in my formula, it is not there as because I have only two independent variable. But if there would be x3, then definitely for x3, I must be used this small x3. So now again, another task is to define then from where we will find out this small x1, x2, x3. Whereas only x1, capital X1, capital X2 and capital X3 values has given to us. So the formula behind this is, As in the correlation analysis, we have seen the in Carl Pearson's correlation coefficient from x1, capital X1, we were finding the small x1, that is the formula for small x1, small x1 was x1 minus x bar. So it is now clear. Suppose I have a variable and having the value like this x1, x2, x3, so on up to xk. Then what I have to do for finding out the small x1? This is equal to capital X minus capital X bar. So for this, I have to calculate what is the summation of xi, that is I varies from 1 to k. Then I will go for calculating what is x bar. The formula is summation xi, I varies from 1 to n divided by n. What was n? Earlier we had discussed n is the set of pair of observation we had given in the questions. So this will give us the x bar value, and what we will do now, we will subtract this value from each individual value of x, x1 minus x bar, similarly x2 minus x bar, this is a capital X bar. In that way, up to xk, we will take the deviation and will take the summation. This is called summation x. So before going to the coefficient formula, we need to calculate the small x1, x2 value. Then we will go to put this value into the b1 and b2 hat problem. Then after finding this b1 and b2, then we will move to the linear equations. 3 linear equations I have given here. Then after solving this, we will move to our original regression model. Let us discuss one problem. So in 9.1 table, I had cited one problem. The first one is respondent, and the second column contains the preference. It is the respondent's preference, that is denoted by capital Y. Then what are the preferences? Now protein, that is X1, then the vitamin D, that is X2. So first respondent, what is the preference? What is the protein unit? What is the vitamin D unit that is given? In that way, the corresponding value has written respectively, and we can see here if we will go for the calculating, the first thing is n. What is the n value? Now we should go for the first column to calculate the n. Now how many respondents are there? 10 respondents are there. So it means n value becomes 10. Now we will go for calculating the multiple regression analysis, which I have done for you, but the calculation part I will do simultaneously here for the easy understanding. Now see. So this is the respondent number, that I have 10 numbers of respondent, and the preference has given that y, and what is the independent variable? The protein x1 and x2. x1 and x2. See, as per our formula, as I said, first what we will do, now we have to go for calculating x bar, which I have calculated here. I have calculated x bar, so I kept blank for another variables arithmetic mean, as because it is not necessary over here. Then similarly, x2 bar is also required, as because another independent variable is x2. So how the x2 bar will be calculated? The same way, take the summation of x2 and divide it by n. Divided it divided by n. The sum of x2 is equal to 40 divided by 10, 4 only. So what is x2 bar? Equal to 4. Now see, so x1, from capital X1 we calculated x1. How I calculated? Now 4 minus 4.3, so it is minus 4 minus 0.3. 9 minus 4.3, it becomes 4.7. In that way I have subtracted the respective x bar from each value of the x, and I have cited in the small x1 column. The same way in x2 also I have subtracted the x bar value, that is 4, from each individual value of x2, and I have cited under x2. Then as per the requirement of the formula, I have calculated x1 bar taking the square of this individual value of small x1. Similarly, for x2 x square, I took the square of the individual value of small x2 I had taken, and again also I calculated x1 and x2 by multiplying the respective x1 and x2 value as I cited under x1 and x2 value. Then y variable value I have cited, small y, after taking the average of y, that 43 divided by 10 equal to 4.3. The same way I have managed, and after calculation of small y, I multiplied small y with x1 individual value, like the minus 0.3 into 4 that I have cited here, 0.39. In that way, the respective x1 value is multiplied with the small respective y value, and I have mentioned. Similarly, x2 y value I have calculated. Now, as per the formula of beta 1 hat and beta 2 hat, I put all the values that from the table contained or calculated and put in the beta 1 hat formula. After putting this value, I find out the value, that is 0.493. Similarly, substituting this value also from 9.8 table, I became able to calculate the beta 2 hat, and the value of the beta 2 hat is 0.484. So what is the next? Now after finding this beta 1, beta 2, as per the scenario, then this value will be substituted in the beta 0 hat formula. Then after putting this value in the beta 0 hat formula, I got it is 0.247. So now what was the sequence? After getting this value, I will move to my multiple regression model. So my multiple regression model was what? Now beta 0 hat plus beta 1 hat into x1 plus beta 2 hat into x2. It means what? As like the previous linear regression model was saying that y wants b0 plus b1 x1. What was happening here? Now suppose we found it is 0.43 plus it is 0.39 x1. It means what? Now if somebody will ask me that, ma'am, if my x value is 115, then could you tell me what will be the value of y for this value of x? I said yes, as because what I can do now, I will put this x value in this equation. If I will put 115 in this equation, after solving this entire equation, what value I will get? This will be nothing but the value of y. But here similarly in the multiple regression equation, this y hat says in particularly for this problem is 244 plus 4.493 x1 plus 0.484 x2. So if this is my equation and questions given to me that if x1 equal to 24 and x2 independent variable, suppose it is test, it is 3, then could you tell me for this value, what what will be the value of y hat for x1 and x2? If x1 and x2 are two combining independent variable that is impacting on y hat, then what will be the answer? Now just simply put the value in the equation, you can easily get the answer for it. Into x was our 24 plus 0.484 into 3. Then solve this equation, what the answer will come, this will be the value of y, which is predicted with the help of these two independent variables. So from the answer, from the equation we can say here b and b2 are called two partial regression coefficient. b1 equal to 0.493 denotes the change in per unit changes in x1 when x2 is equal to constant. And similarly, B2 says 0 equal to 0.484 denotes a change in per unit change in the x2 when x1 is noted as constant. But these are the situation in the partial regression model when we are assuming that other independent variables are constant and only one variable, how much it is impacting, or the other dependent variable that is calculated. The same thing also we can do as yesterday we discussed, that if the data set is very small, or we can say we have only 10-15 data, then we can go for manually we can calculate, but it is not possible for the industry or any manufacturing company as because the data was too large. So in that case what we will do, now we will take the help of the statistical tools for the analysis of the multiple regression calculation of the similar data. So what we will do, after entering the data, we will go to the analyze button. You can visibly see in the taskbar. Then we will go for the regression, and in regression we will go for the multiple regression or multiple logistic regression, any type of regression what we want, or linear regression. Then after selecting that, we will move for the preference by clicking the right arrow and then transfer it from the variable. As it is seen here, I have two variable. One was protein and second one was vitamin D. So what I have to do now, preference will be the dependent variable, as because preference depends upon the protein and vitamin D. So protein and vitamin D will be selected and to be forwarded to the independent variable box. It is visible here in the right hand side of the slide. So by selecting them and by giving the right arrow, it will automatically move to the respective box. Then we will give the parameters from the statistics or any plots if I want to calculate, then that will be chosen from the systems. Then we will move to run this solution or run this program by clicking OK. So after that, after enter button, then SPSS will give me a table of summary, or you can say it is model summary. In the model summary, what is the R value, what is the R square value, adjusted R square value, estimated error, all these things are given. As it is clearly mentioned that predictors are vitamin D and protein. The meaning is very clear. As per the regression, the preference is purely depending upon the vitamin D and the protein. Or we look first the coefficient of the multiple determination, that is R square. R square is what? Now it explain the variability. So what is my R square value over here? 0.783 and R value is 0.885, which is a satisfactory one, indicating that the preference rating Y is linearly related to the protein intake X1 and vitamin D intake X2. It tells that 78.3% of the variation in Y is explained by these two independent variables. As in the regression, we know that the extent of variation is explained by the independent variable. So why we are saying it is the summary of this particular model is sufficient? Because the explanation of dependent variable by this two independent variable, vitamin D and protein, is satisfactory, that is 78.3. It means vitamin D and protein is explained 78.3 percentage to whom? Now to the dependent variable preference. So if this is the process, then how we will execute in our research methodology or in the marketing research project while compiling or completing the research project. So as per the rule, or we can say as per the steps of the state testing of hypothesis, we have to frame the hypothesis first. So what was the hypothesis priorly discussed? It is null hypothesis, which is denoted by X, and the alternative hypothesis, which is denoted by H1. So H0 says status quo, as earlier we discussed. So what I written here, there is no relationship. There is no linear relationship between Y, X1 and X2. It says the null hypothesis. But what about the alternative hypothesis? There is as we understood that, what is the relationship between H1 and H0? Now what H0 says, the H1 is just the mathematical opposite. If H0 says it is equal, then definitely H1 will say it is not equal. The same way, vice versa, if H0 will say it is not equal to, then H1 will say it is equal. So what we have seen here, initially the researcher what assumes in the null hypothesis, that there is no linear relationship between Y, the independent variable, with X1 and X2, who are the independent variable in the given problem. But what is the formulation of H1 we have done? Now H1 says, there is a relationship between Y, the dependent variable, and the other two variable X1, X2 are the independent variable. So what we found, now by seeing the summary table we got from the SPSS table, that ANOVA, F statistics says it is 12.65. I think it is mentioned here, it is 12.65. And after getting the it was the F value, means the calculated value. As per the rules of testing hypothesis, if the calculated value is more than the tabulated value, then the null hypothesis will be rejected. Let us see what is our tabulated value. Now tabulated value is the table, nothing but the table value. Particularly in the ANOVA, analysis of variance, we are applying F statistics, and in the F statistics there is no need of any level of significance, but we have taken 5% level of significance, and we took the degrees of freedom 2 and 7. So as per the 5% level of significance with degrees of freedom 2 and 7, the tabulated value is 4.74. So let us compare now with our tabulated value with the calculated value. So calculated value is priorly with us, that is 12.65, whereas our tabulated value was 4.74. It says the calculated value is more than this tabulated value. So it means this value is exceeding this value or moving towards the rejection region. So it means you should have to reject the H0, and if, as we know, if we are rejecting H0, definitely we will accept the H1. So here in this particular case, we are accepting H1 or alternative hypothesis by saying that, by concluding that there is a relationship that mean otherwise, or we can say there is a linear relationship between that independent variable Y preference among the two independent variable X1 and X2, which is nothing but your vitamin D and the protein intake. We can conclude in that way This illustration has been given here. So you can see clearly 12.5652 is calculated value of f, and the tabulated value we had calculated, we have seen from the, or we can say we have collected from the table only. So how the, let us come to the point where we have written the regression, multiple regression model, how it looks like. So you can see here y is the 0.247 is our constant, b0 you can say. It is the x1 independent variable, and the coefficient, or you can say slope of this independent variable x1 is 0.49 plus 0.48 is the coefficient of x2. So you can say here the estimated equation I had written, and if we elaborate it, it indicates that the protein intake is positively related, because both positive sign before the x1 and x2 variable, related with preference for ready to eat cereal, as it is evident from the positive value of the coefficient. As because it is positive, so we have to ready to take it. The same way in the vitamin D also, the positive coefficient 0.48 it also indicates the same. So the equation should be validated, or how we will consider this multiple regression analysis. It should be validated statistically for forecasting the dependent variable with the help of independent variables. And also we can do one thing, the most and foremost important in the multiple regression context. No doubt we are using regression model to predict the variable, or we can say how they are related with each other and what is the degree of association between them. No doubt we are measuring. But the most challenging situation for the researcher is what is the situations, and whether the situation or the whether the problem is well defined, and whether the problem is asking or requiring this multiple regression. If it is so, then another challenging thing is which one is the independent variable, and what are the combined, or you can say what are the set of independent variable, and what are the dependent variable, that should be understood first. After that, we should understand whether independent variable which we have counted, are they really impacting them? That need to be studied. If it is manually understand, then it is well and good. We should keep or we should not keep. That will be decided. And once we will decide it, then we should go for all the tests like ANOVA, t-test, and the all normal linear regression, normal linear equations to find out the coefficient which will be applicable in the regression multiple regression model. So multivariate regression models have been illustrated in this model, or you can say in this unit, and by giving the one example which was the best for the marketing research, the customer preference rating as a function of protein and vitamin D intake. In this case, a ready to eat cereal survey was there. It's the same kind of survey a person can take in before launching the product, or suppose in the product in the market also, what is the performance and how it is not growing or improving, and how it will improve, what independent variables need to study, that will also can be measured from the use of multiple regression model. That will tell us whether the variable we have decided is really impacting the dependent variable or not. These things will clear us how to invest on, or we can say on which variable we should work more, and which one should be neglected, so that our model can run faster and smoothly, and we will get a valid conclusion from our research. So finally, the problems encountered in any regression analysis have also been explained, and also we have given emphasis on the neglecting variable and the variable which to be studied in the multiple regression analysis. So which one is the most important one? It is the done also partially, and we can say the another concept is partial regression model, which we can study by using this multiple regression. If a researcher wants to study only the impact of x1 remaining constant the x2, actually I have n number of variable, but I want to study only 2 to 3 variables impact on the dependent variable, but remaining other independent variable to be constant. So that is also helpful by using this multiple regression model. So it was all about the multiple regression model, which is the most important tools for the marketing research and forecasting. Thank you for today's chapter. Thank you again.